All right, next up, I want to bring on Hart from across to tell you about how do we make intents and interoperability better. So please give Hart a big round of applause.
All right, guys, how y'all doing? I'm going to try to keep this exciting and interactive since you guys have had a bunch of talks. Okay, so I'm Hart Lambur. I'm co-founder of Across. I have another protocol I worked on called UMA that has left me knowing Kartik and the ETH global community for many years now. UMA is best known for supporting polymarket prediction markets right now. Coming out of that, though, we built Across too. And let's level set here. So the problem that Ethereum had in 2020 is that it was expensive and didn't scale. You guys remember DeFi summer? Lots of fun usage, crazy transaction fees, crazy congestion, didn't quite work. Everyone invested really hard in scaling Ethereum, and it worked. I don't know what your recent experience is, and I think sometimes in Ethereum we don't celebrate our successes enough. But Post-Dencun, just earlier this year, L2 transaction fees are dirt cheap, speeds are fast, feels like Solana, feels like a Web 2-like experience. It's pretty amazing. And one like nerdy slide for the data nerds in the audience. We saw this in our data as a cross-chain bridge or interop solution, which I'll get into. But the average transaction size of users bridging L2 to L2 dropped by 10x with Dencun. So now people are bridging $50 commonly between chains. And they're doing that because it's cheap. We made Ethereum cheap and scalable, and people actually start using it. So I feel like that's very bullish for what we're trying to build. But we have this new problem now. The new problem in 2024 is there are too many blockchains, and the user experience for moving between them is absolutely horrendous. So what does the UX for moving between, for using a cross-chain application look like without intents? I'm not even going to read this. It's like go to dApp website, connect chain, figure out which way to bridge, go to the bridge website, connect chain, bridge money from A to B, wait a long time, go back to the original tab, switch wallet back to chain A, use dApp. I stole this from Uma Roy, who presented on this about a year and a half ago, and this takes like 10 minutes. You got 5 tabs, you've got 3 wallet connections on 2 chains. It absolutely sucks. This is never a way we are going to have 1 billion users use crypto. It just isn't going to work. So what do we want? What we want, cheap, fast, secure interop, so seamless, don't even know you're using blockchains. Users want to click buttons. They want to click buttons and they want things to happen. They want them to happen quickly. They don't care about the other stuff. We do, because we're nerdy builders, but they don't. And so the spoiler alert, yeah, I'm biased. This is what we're building, but we can solve this with intents. And I don't have permission to play this file. Damn it. I wanted to do a demo of Across here for you guys, and I didn't think Kartik was going to let me use his computer to sign transactions. So I recorded a little demo of what Across looks like. You guys should all go do it. If you're like on your phones and tired of listening to me, go to across.to and go and bridge between a couple blockchains. I just recorded a demo earlier. We've moved $20, cost less than 4 cents, and it took all of 1 second to go from, I think in my example, it was our, Optimism to Arbitrum. So we have the technology, and I'm going to go into how we do this. But we have the technology, we have the ability to move assets between blockchains with an experience that is Web 2-like. I probably shouldn't stay on this slide because it just looks broken, but there's a cool demo. Go to across.to and you guys can check it out. There we go. And what my demo was going to show was this example of using Across in its own application, but what we're working towards and what this intent narrative allows is you can build this into your dApp itself. So this is a GIF of co-finance, which is integrated across to fund a DeFi position from any chain. And if you think about what's happening here, they're just saying, Cove is saying, here's the transaction I want to execute on this chain. I forget what example this is, but here's the transaction I want to execute on Arbitrum. and I want to be able to pay for it from any chain I have funds. And I mean, honestly, this is solving the UX problems. Okay, but I'm gonna run out of time because I want to tell you guys how this works. So we'll transition away from the user experience, which I think is so important to solve, to talk about how intents actually do their thing and how this differs from what I'm going to call traditional bridges or traditional messaging. Okay, interoperability. I've got 2 blockchains. How should I connect them? Default model that people think of is this should be like TCP/IP. It's like I have web servers and I plug them in with Ethernet cables and they talk to each other using messaging. Makes sense for the internet. My argument is it does not make sense for blockchains. And here's my example. Okay, so blockchain A to blockchain B, send a message. What are the problems here? Well, in order for me to do this, blockchain A, I gotta wait for finality, or at least a sense of finality on blockchain A, and then I gotta wait to send a message, and then I get to blockchain B, and then I can do my thing. And outside, I'm gonna go through why I think this is not the right security or cost structure, but purely from a speed perspective, you are screwed if you wait for this architecture. You will never have a 2-second-like experience, at least with chains like Ethereum and its L2s that don't have a sense of very quick finality. So you'll just never have a user experience that works here. So I think using this kind of traditional approach to send messages, it's not gonna give us the UX we need. The solution is you simply stop sending messages. You do this asset transfer without sending a message. And the observation here that enables this is that TCP/IP is about moving bytes. It's about moving bespoke messages between servers. Blockchains are mostly about moving value, moving fungible money like ETH from chain A to chain B. Maybe I want to execute code with that value on my destination chain. I want to execute some transaction, which intents support. But the fact that we're all about just moving value means we can use this fungibility to solve this cross-chain UX problem. If I'm moving money, I simply do not care which money it is. I just want dollars. I don't care if it's that particular Ethereum. That doesn't even really make sense. I just want one Ethereum on my destination chain. And this core observation is why we pushed on this intent design and why we think it works so well. So, what does bridging with intents looks like? It looks like you don't send a message. You don't send a message at all, at least initially. Rather, the user deposits on blockchain A their intent, and their assets go into what's effectively an escrow contract. Excuse me. Their assets go into what's effectively an escrow contract. Third party solvers, we sometimes call them relayers, are observing that intent, and then they are competing to fill the user with their own money on the destination chain, on blockchain B. So what happens here is we've actually transferred the finality risk and the reorg risk to these sophisticated third parties, the solvers, and they're going to compete and race to fill the user. And if my demo worked, you'd see that they can do this in like a second between blockchains because they're able to price the finality risk and take it on and give the user an amazing experience. Once the user's filled, the protocol then verifies that the intent did in fact get filled before releasing the escrowed user funds back to the solver. So that's the core architecture, and maybe that's a lot, but we'll go through it and I'll tell you about some of the advantages here. So, TLDR, cross-chain intents, solvers fill users with their own capital quickly and cheaply, and then they get repaid later. And in this, there's no message that gets sent to fill the user. The messaging is used later on to verify that the intent was filled and repay the solver. Okay, so our structure here. I like to think of this architecture as having these 3 layers. Looks like a cake. We're stealing this term cake from our friends at Frontier Research. So the intent layer, user or application says, here's what I want to do. Mental model, think of it like an order ticket. The user is saying, I have asset A on chain X, and I want asset B on chain Y. And then they sign that message. That's the intent. That intent then gets distributed to a solver network that's going to race to compete to fill that. And meanwhile, the settlement layer is escrowing the user assets and only releasing them back to the solver after we verify that the intent is filled. So that's our architecture there. And this can be really, really fast. My demo didn't work, but we got data here. So across, for L2 to L2 transactions, these numbers are actually going to be pretty small, but our median fill time is 3 seconds. And there's room for us to get faster than that still. But 3 seconds is like 2 orders of magnitude faster than our competition, 1 to 2 orders of magnitude faster. And I think it's actually a qualification for the type of user experience we need. I have Stargate. I like to battle with Stargate on Twitter. Stargate is this traditional bridge approach, and their fill times are more on the order of a minute or 3 minutes, depending on the option you're picking. And that's simply because they need to wait for finality, and they need to wait to send a message. Different architecture, not as fast. But the other advantage of this that I think is overlooked is security here too. So we should at least care about decentralization in our industry to some extent. And if you're trying to send a message very quickly in real time, that's a very hard thing to do securely. At least it's very hard to do that securely and cheaply. So Intents has this security property that's pretty nice, because what we do is we separate the urgent part of what the user urgently needs, which is a fast fill. We separate that from the complex part that's hard to keep secure, which is verifying that an intent was filled correctly. And in doing so, we buy ourselves time. So user gets their fast fill, but then we can take all the time we need to verify that fill was in fact correctly filled, and we can use the best messaging technique available to do that. It doesn't matter whether we use canonical bridges, which is the way Across today is mostly built, or we use ZK proofs, we use optimistic systems, we use ecosystem native interop, like Superchain native interop fits very nicely in here, all sorts of advantages. So they let us maximize security while not sacrificing the user experience. And Intents can be really cheap. So one of the major advantages is that we're able to batch verify all of these intents. And if you think about that, and I'll go in more detail on the other slide, messaging has a cost. It has a cost from a gas perspective, and it also has a cost where you have to pay your messaging provider something for security. So if we're able to compress thousands of intent transactions into one message, we can amortize the cost of messaging over many, many, many transactions. And so here's some other data, again, looking at across. Our average cost on an L2 to L2 transaction is 4 cents, and there's room for that to go lower. Some of the traditional bridge approaches, Stargate's bus is 6 cents, 5 cents, 6 cents average cost. This isn't exactly apples to apples because we got to look at trade size, but the point is we're really cheap here too. And so going a little bit more deeply, like kind of creating a theoretical model for where this cheapness comes from. Let's assume we're moving $50 million over 50,000 transactions, and we're going to batch these together in a 1-hour period. So our solvers in this network, they're going to be lending $50 million for an hour, which sounds like that might be expensive. But then if you kind of do the math around this, a 10% interest rate for 1 hour is on 50 million bucks is $500. That's the total cost there. And so we pay $500 in quote unquote interest that our solvers need to get compensated for. And we send a few messages to verify that. Costs us about $500 in total kind of security costs to verify those 50,000 transactions. Meanwhile, if you're sending 50,000 transactions and they cost you 5 cents to verify, you're going to end up spending $2,500 in like a traditional approach. Here's where I'm picking on Stargate. So that's kind of our trade-off, our theoretical argument as to why intents are in the long run actually cheaper still. So I'm actually doing okay on time here, but okay, what are we doing with Across? So Across is an intent-based architecture for interop. We have a settlement system that supports cross-chain intents that really looks something like cross-chain limit orders with some extra features, like I can execute arbitrary code on the destination chain. And we've been positioning across more as a platform to support intents from anyone that wants to build on this standard. And with that, we actually introduced a standard. So we co-authored ERC-7683 with our friends at Uniswap. This is a standard for cross-chain intents. And what it's meant to do is help create a common language for what an intent looks like, so that we can have solvers that can fill intents specified in this common standard. And our thought process here with our friends at Uniswap is that there's going to be lots of intent protocols that are competing, but all of them want the deepest, most liquid solver network. And so if we make it easier for solvers to support different types of intent protocols because they conform to a common standard, it's positive sum for everybody involved. We are able to have deeper liquidity and a better user experience. So that's what we did. And encourage you guys all to go check out ERC-7683. We have a website. This standard is in draft mode. We want feedback. And our thought process here is, again, we don't think that interoperability is going to be solved with vendor lock-in or with one provider kind of being the gatekeeper of this cross-chain interop experience. We do think that there's a need for standards here because there are going to be many approaches that are going to be complementary to each other. And some other news. So one of the things that I look at from Ethereum's perspective, we have these L2 ecosystems that are awesome in how they're innovating. You have like Optimism Superchain innovating in one direction, Arbitrum Orbit, the Scroll folks, we heard from Sandy earlier, ZK Sync, Polygon CDK, they all got their own architecture going on, and I think that's something that within Ethereum we celebrate, this diversity and this kind of push for innovation in new directions. All of these ecosystems are also trying to make their own chains talk to each other better. They're developing techniques for native interop between them. But if you then zoom out and you look at that from the perspective of a standard Ethereum user, you've got this like horrible user experience again, where I don't know how to go between these ecosystems. It's like Ethereum is being splintered into walled gardens. And so our solution to this is actually using this intent standard as this lightweight, simple to reason about layer that connects these different ecosystems within Ethereum. And our friends at Optimism, and amongst others, we're close with all of the roll-up ecosystems, they see the value in this too. And they want to use this standard that we're pushing with Uniswap as the basis for Superchain Interop. So they're going to have the same sort of super fast user experience between superchains powered by this intent standard that doesn't just allow you to move assets or do interoperable transactions between the superchain. It also lets you go in and out of the superchain from Arbitrum, from Polygon, using the same architecture that we're promoting. So we think that's pretty cool and pretty exciting. Yeah. And so on our roadmap, we've been pushing really hard at being fast. That's been our push for the last year, fast and cheap. We care more about speed than we do about cost right now because we really do think the user experience is what matters most. And now that we're down to like 2 basis point like fees for user transactions, it's getting so cheap. That's not the hurdle that's preventing users from adopting Web3 dApps. The hurdle is UX, and it's that user experience. So our focus now is bringing intents to more chains. We're on 13 chains right now. We've got 10 more in the pipeline, some very big ones launching very soon. And we're trying to get to the point where this intent architecture can be a day one architecture, day one on every new L2 that launches. And that's it. That's my presentation. I'm Hal2001 on Twitter. And yeah, hit me up and we're happy to talk about the future of intents.